Alright, LeetCode 80. Remove duplicates from sorted array part 2. The gist of this problem is we're given a nums array which is sorted in increasing order. Now within this nums array, there are numbers that contain duplicates, so they appear multiple times. And what we need to do is we need to remove some duplicates in place such that each unique element appears at most twice, and we need to maintain the relative order of the elements. So before we look at an example, what makes this problem difficult is that in the description, we're actually required to solve this in O of 1 extra memory, and of course it has to be as optimal as possible. And also what's provided in the description is that what we're actually returning isn't the sorted array, but rather the first k valid elements in our new sorted array. So let's go ahead and look at an example to see what we actually need to do more specifically. So as you can see in example 1, we have the nums array 1, 1, 1, 2, 2, 3. And so because 1 appears more than one time, it appears 3 times, and it's only allowed to appear twice, we need to sort that out. And as you can see in the sorted array, our final nums array is now 1, 1, 2, 2, 3. Now really what happened is because we can't destroy an array's length in Java or modify it, what happened is we just moved the 1 to a different position in that array, and we return the first k valid elements. Similarly, in example 2, we have 0, 0, 1, 1, 1, 1, 2, 3, 3. So the 1, 1, 1, 1 is not valid. And our final nums array looks like this: 0, 0, 1, 1, 2, 3, 3. After we fixed it, the remaining 2 1s are now in the end of the array, but because we're only returning an int of the first k valid elements, then our judge compiler is first gonna check the number of valid elements if it's correct, and then it's going to scan our array to see if those k valid elements are correct in our array. So let's go ahead and get started. Oh, and before we begin, do you need help bringing a digital idea to life? From designing to developing a website or an application, look no further than Evolve Consulting. We work fast, we're affordable, and we even offer free consultations. We'll get your app running in no time. So what are you waiting for? Reach us on LinkedIn or through any of the contacts on the screen. Alright, now let's get back to the video. So I'm gonna go ahead now and create our count and our first pointer. Now what I'm gonna do is in a for loop, I'm going to create our second pointer, and our second pointer, we can call it P2, is going to keep looping while we still have numbers to loop through in our nums array. So in other words, while P2 is less than nums.length. And obviously we need to increment our P2 with every iteration. So let's go ahead and write that. So now what I'm gonna do is I'm going to check what P2 is looking at, and if what P2 is looking at is not the same as what P2 was looking at the previous iteration, so P2 minus 1 or the previous element, then I'm going to reset our counter, or I'm going to set our counter to be equal to 1, meaning this is the first time we've seen this element, and so far we've seen this element once. Now another thing I'm going to check is just the initial iteration where P2 is equal to 0. We still need to set that count to be equal to 1 to account for the first time that we're seeing the first element in our array. So basically, if P2 is equal to 0, or the element that P2 is looking at is not the same as the previous element that it was looking at, then let's set count to be equal to 1 to account for the element that we're looking at right now. This is the first time that we've seen this element. So let's go ahead and write that down. Okay, so now what I'm gonna do is, like previously discussed, if our count is less than 2, remember our first pointer, which is our writing pointer, which will override values that it's looking at. If our count is less than 2, then we're going to replace what our first pointer is looking at with what P2 is looking at. And then after we do that, we're going to increment P1 to look at the next element. However, if count is greater than 2, then we're not going to increment our P1 pointer. It's going to still look at the very same element that it was looking at until P2 sees a new element, where at that point our count is going to reset to 1, and then that value will be overwritten. What P1 is looking at will be overwritten with what P2 is looking at. So if we look at example 2 to just explain what I mean, we first start off with 0. P1 is looking at 0 and P2 is looking at 0. Since P2 is equal to 0, we're going to set our count to 1. This is the first time we see a 0. So this is the first 0 that we've seen. And then we're going to check if count is less than 2, which it is. So we're going to overwrite the element at P1, which is the element at index 0, which is coincidentally also 0, to be what P2 is looking at, which is also 0. And then we're going to increment our P1 to look at the next element, which is also 0. And in our next iteration, P2 will also increment. So now it's also looking at 0. And now since the element that our P2 pointer is looking at is the same as the previous element which it was looking at, we're going to increment our counter to track for this 0 now. So now our counter is 2, which means this is the second time we've seen a 0. And since count is still less than 2, or less than or equal to 2, we're going to overwrite what P1 is looking at, which is index 1, which also looks at 0, with what P2 is looking at, which is also 0. And then we're going to increment our P1 to look at the next element, which is 1. And now we're in the third iteration where P2 is also looking at 1 because P2 is at index 2 now. Since 1 is a new number, we're going to reset our count to 1. And then we're going to overwrite this 1, what P1 is looking at, with P2, which is 1. And we increment again, so P2 and P1 are now looking at this. Count is going to increase since it's the same as the previous number. And then we're going to look at this. At this point, count is now equal to 3. And so what we're going to do is we're going to keep our P1 pointer right here at 1. And we're going to increment our P2 pointer. So now P2 is looking here. And since this is also 1, we're also going to increment our count. And one more time, we're going to loop. So P2 is now looking at this 2. And since this is a new number, we're going to reset our count to 1. And now, since count is less than 2, less than or equal to 2, we're going to overwrite what P1 is looking at with what P2 is looking at, which is 2. So now this value, what P1 is looking at, still highlighted in blue, is now going to be at 2. And now finally, P1 can look at this number now, while P2 is now looking at this 3. And since 3 is a new number, we're going to reset our count to 1. And we're going to overwrite what P1 is looking at with what P2 is looking at, which is a 3. And now we can increment one more time. P1 is looking at this, while P3 is looking at this, or P2 is looking at this rather. And this is the last time we're going to overwrite what P1 is looking at, and we're going to replace it with a 3. And we're going to iterate one more time, but we're out of elements, so we're going to exit our for loop. And at that point, all we need to do is return P1 because that's the final index which we've replaced, the final valid index. So that's the entire solution. And one more thing I want to point out is because I didn't complete this if-else statement, just to make it clear, just to clarify, if the element that P2 is looking at is the same as the element that it was looking at before, so the previous element, we need to increment our counter, and we'll do that in an else statement alongside the rest of the code. So let's go ahead and write the final solution now. So that's the entire code. Let's submit and see if it works. Yeah, and there we go. So that was the remove duplicates from sorted array part 2 problem on LeetCode. I hope you stuck around to see the example we went through in the middle of the video. Otherwise, I hope you found that video helpful, and thanks for watching.